Hello, my name is Andrzej Wróbel. I'm a sensor architect within TADDM development team. Today I'm going to show you great improvements in storage area in TADDM. The first topic is HBA firmware discovery. Second, enhanced discovery of TPC sensor and new storage objects in TADDM user interface. The last point is introduction of new sensor for EMC storage scope software. At the beginning, we should ask why we want to discover more detailed information about HBA cards. The attributes like manufacturer, model, and serial number are required for inventory purposes. A key attribute is firmware. User can collect this information from all HBA cards that are running in the client infrastructure. Next, the value of firmware can be checked for any mismatches, which is a common cause of outages. TADDM administrator collects that information using storage collectors like host storage sensor. In TADDM version 7.1, a list of worldwide port names was available from the user interface. In the next version, there are major changes to the same view. A list of detailed attributes is displayed as it is presented on the screenshot. Especially, firmware can be checked. The next point is enhanced discovery of TPC sensor and new TADDM objects in TADDM user interface. For this point, I'm going to show business scenario, sensor changes, new objects in inventory summary, and a live demo. Many times, clients have TPC product scanning IBM and non-IBM storage array. System administrators do not want to deploy TPC agents on hosts, especially on those connected to non-IBM array, to reduce maintenance and number of running applications. On the other hand, they request to see relationship between host and array. In the upcoming TADDM version, TPC sensor was extended with a new query called host.scsi agent less. The query discovers information about array name, volume name, LUN ID, and fiber channel ports that are involved in the communication. The solution is to use discovery performed by host storage sensor that collects host worldwide port names and match this information with TPC data. It is important to understand that LUN IDs must match on both sides. In addition, TADDM user interface was enriched to show graphical representation of fabric and zone-related objects. Now, I would like to present live demo of the functionality I just talked about. We start in the Discovery Management Console by running Discovery. I select IP address of Linux host that has HBA API library installed. I select a profile with the host storage sensor enabled. Discovery starts by establishing SSH session to the host, and then host storage sensor starts. When discovery is done, we can check results in Data Management Portal. I'm using search function to find my Linux host. I select Details button to bring detail panel for this system. I go to the Storage tab, then Storage Volumes and Fiber Channel Volumes. We can see that the volume SSD does not have storage subsystem or based on links populated. Next, we run discovery of TPC. Note that with the new query, the number of discovered objects has increased, which extends storing time. When discovery is done, we can again check Linux details. The links are empty, so we have to wait for the topology builder agents. We can check when they ran last time in the status view. After the dependency group is finished, we navigate back to the Fiber Channel Volume tab. The links are now available. Note that to get this view, the LUN IDs must match. TPC sensor discovers fabric-related objects. We can find them in the inventory summary. The storage section has a new icon for fabrics. We can list them and select details. The fabric objects in the detail panels has general attributes as well as a tab for zones, zone set and fiber channel switches. Thank you for this point. I would like to move to the last point of our demo, which is new sensor for EMC storage scope. The agenda is following: business scenario, sensor architecture, sensor configuration, live demo. EMC is a common storage provider. The next TADDM version has a new sensor for EMC storage scope. By collecting data from EMC, TADDM administrator can get a top-down view of the business application, that is, starting from the business process through applications, systems, down to the storage arrays. Additionally, user gets insight into fiber channel relationships between components in configuration management database. On this slide, you can see EMC sensor architecture. Flow of the discovery is following. TADDM finds that on Windows machine, EMC storage scope service is running. Next, it finds configuration file from the service arguments that keeps URL to EMC database. EMC sensor establishes JDBC connection to that database. It is required to add credentials in the access list for the Oracle database. When SSL is enabled on the Oracle database, user needs to provide wallet file that has certificate inside. The name of the database that TADDM is using for collecting the data is EMC STSDB. It is important to understand how the sensor works. Basically, discovery is split into two sensors. The first one is called EMC storage scope sensor, which acts as the primary one and is discovering objects like fiber channel switches, fabrics, fiber channel relationships, and shallow array. Second sensor, EMC storage scope detail sensor, was introduced to improve scalability. The purpose of this sensor is to discover deep information on the array, disk drives, logical devices, and all hosts that are connected to the array. EMC storage scope sensor is enabled by default in the Level 3 profile. It has a number of configuration parameters. Arrays discovery chunk. This parameter controls the number of arrays that are processed by each EMC detail sensor. For example, if EMC storage scope returns 15 arrays, TADDM will start two EMC detail sensors. First will process 10 arrays and the second one 5. The next parameter is to limit the number of arrays to be discovered. User can specify serial numbers of arrays that needs to be discovered. Others, even if they are found in EMC database, will be skipped during discovery. The rest of the configuration, that is discover host and discover switches, control if the user wants to discover respectively host and fiber channel switches. After successful discovery, we can see number of objects stored in TADDM database. Now I would like to show you live demo of EMC data. Basically, EMC is sharing the same common data model objects and user interface with TPC. In inventory summary, we can find storage section. We select fiber channel switches to show the relationships. For this, I will use node-centered topology to get a list of dependencies for the selected fiber channel switch. After getting topology, we can navigate to detail panels by right-clicking on fiber channel switch. The General tab contains attributes like model and manufacturer. We can also see the fiber channel port stub. Now I would like to show you the business application that contains software running on AIX host that has a connection to the storage array. I select Show Physical Topology to see the relationship from business process to the storage array. I select Details of AIX host. Note that this AIX host is a shallow object created by EMC detail sensor. Therefore, an attribute isPlaceholder is set to yes. We navigate to the Storage tab, Storage volumes, and Fiber channel volumes. We can see links to storage subsystem and to logical devices. For the volume opt IBM, we see a list of devices. It means it's a meta device on EMC array. The current version of the sensor does not support directly link to EMC meta devices. For the storage array, general attributes are discovered, as well as a list of physical disk and volumes. The list of volumes contains links to computer systems, if they are available.